PES is photoelectron spectroscopy. So you're given a spectrum that has energy on one axis and the relative number of electrons on the other. One thing you need to be careful of, and this can change depending on the source you're looking at, is which direction the energy axis goes. A lot of AP exams have it going from high to low. Some graphs you'll see have it going from low to high. What I mean by that is here, where this is the highest energy value, this is a measure of how hard it is to remove an electron from an atom. So higher energy means harder to remove. The electrons that are hardest to remove are the ones closest to the nucleus. So lower energy is easier to remove. With that knowledge, I'm able to go through and label my electron configuration. So the one closest to the nucleus is always the 1s subshell. And this has, if it's full, it's going to have 2 electrons. After there, we go to 2s2. Then we go to 2p. Notice that the 2p peak is 3 times as tall as the 2s peak. It's 3 times as tall because it has 3 times as many electrons in it. After there, we go to 3s2 and then 3p, and the 3p also appears to be full. Labeling those, I can then answer these questions. Right, the electron configuration, pretty much just did. 1s2, 2s2, 2p6, 3s2, 3p6. Identify the element. If it ends in 3p6 and it's not an ion, it's argon. C is asking me to explain, excuse me, why peak A and peak B are at different places on the x-axis. The location on the x-axis is how difficult the electrons are to remove. So peak B is at a different place on this axis because its electrons are closer to the nucleus and therefore harder to remove. Or I could say conversely that peak A, its electrons are at a lower energy because they're farther from the nucleus, held more weakly, and easier to remove. Okay, this says that I have the PES for lithium. So lithium has an electron configuration of 1s2, 2s1, which we can see reflected here with the 1s2 and the 2s1. I know that it's 2s1 because it's A, lithium, and B, half as tall as this other peak is here. Helium is 1s2, 2s2. And helium has helium has 2 protons. Let's try that again. Helium's just 1s2. Helium has 2 protons, lithium has 3. Since lithium has more protons, it's going to pull its electrons more tightly. Helium's electrons are easier to remove than lithium's because they're farther from the because helium has fewer protons, its electrons are easier to remove. So its peak for 1s2 would be shown here at a lower energy than that peak there. So helium was the one I did in pink. Now, if I were going to add in a graph for boron, boron is 1s2, 2s2, 2p1. And boron has, let's see, 5 protons. So since boron's going to pull on its electrons more forcefully due to having more protons, I'm going to show its curve at a higher energy. There's boron's 1s2, 2s2, then 2p1. On the AP exam, you would be asked to deduce electron configurations from photoelectron spectra. You would be asked to compare locations on the x-axis, which is a measure of how difficult the electrons are to remove and how tightly they are held to the nucleus. I believe on the AP exam now, they tend to go from high, and on the x-axis, they tend to go from high energy to low energy, which is not normally how you make an axis, but for ease of reading an electron configuration, it's easier. So I would read it from left to right more typically, going 1s2, 2s2, 2p6, 3s2, 3p. I didn't make this very thoughtfully. 4, maybe. You can, on an actual one, you would have lines so you can deduce it a little bit better. But so you want to be heads up for the direction that the x-axis is lined up.